All right, well, happy Thursday again. We're going to talk more about arrays and vectors. It's lots of fun stuff. So in the video we did, the Connect 4 was a two-dimensional array. Did anyone get working on the lab? Just an easier, just a tic-tac-toe example? Yeah, how'd that go?
Pretty good.
Okay, cool. It's just practice, so using things, when we think in two dimensions, right, rows and columns, they're not really in rows and columns. It just makes it easy for us to kind of conceptualize that. And if you want to get crazy, right, you can do 3 dimensions or 4 dimensions or n dimensions, but beyond 3, it hurts my head, and I can't think anymore beyond that. But you can, right? As many as you want to stuff in, you can stuff vectors inside of vectors inside of vectors inside of vectors. So yeah, if it stops making sense, we should probably find another way to do it. It's sort of the idea there, right? You don't you want to use it if it makes sense for you. Here, sorry, I put that on silent. All right, so let me fire up Visual Studio here. And then how's the project going? That we've got that due next week. Anybody start? Not start? It's okay. So next week we'll go over the solution 9:30 in the morning. So if you have questions about the labs, we can chat about the labs. I know a couple of people were still having some trouble on 1 or 2 of them. That's okay. So we can talk about those today or Tuesday, whenever you want here. So again, this is dealing with all sorts of fun pointer stuff. We're using dynamic arrays, constructors, destructors, copy constructors, copy assignment operators here. And I did fix that problem I was having. That's what it was. It was the pointers one, right? I think it was the pointers project where it wasn't copying right. I figured it out. Let's see, did I leave the note in here? Yeah, so when we did this version here, the copy constructor was working fine, but then it was hitting the assignment operator, which we hadn't written yet. Once we wrote the assignment operator in the student class, and we could assign to another one, then it started working just fine, and that scores array was okay. So this was making a copy of this one and then assigning it. So this is kind of redundant at this point. You don't need to do both of these, right? Because if our assignment operator is making the copy, we've now made a copy and then made a copy of the copy. So we're doing too much work here, right? It'd be just as easy to assign because it makes the copy if we've written the code to do that, right? So that's the idea. If we're using dynamic memory, we want to make sure that when we assign things or when we copy things, we're getting new dynamic memory. So we don't have 2 pointers pointed to the same place in memory. So that's going to trip you up here on this one, especially if you start doing fights and things like that. It would cause some trouble, right? That's all. So we're not actually fighting with the fighting pets yet, but that would be the next stage, right? We can make these things fight. But if we both have the same fighting pet, it'd be sad if your pet got knocked out and my pet got knocked out because your pet got knocked out. And then we would not be able to catch them all, and we'd be sad. That's all. So as we're working through that, right, make sure we're getting these copies going the right way and test it out. Okay? That's all with this one. So there's a lot of moving pieces to it, but it's not terribly hard. It's just we have to make sure we're covering all of our bases there. Okay? All right, cool. So let me close that one. Oh no, close the solution. And let me go open this one up. You need to talk any more about Connect 4? Was this one okay? This was okay? All right, cool. So again, just breaking stuff up is lots of fun. I love breaking things up into smaller and smaller and smaller and smaller pieces. So it doesn't really matter too much that some of these methods functions are private. Ideally, if it doesn't make sense for someone else to use them, you should put them in the private section, right? Like no one is ever going to look specifically if there's a winner horizontally. That's just one of those ideas. When we're doing our object-oriented design, right, we're encapsulating all those details together into one nice little package. And then with that idea of abstraction, they're getting the public pieces. All they need to do is know that they can call these public functions, like make a game, drop a piece, get the current player, get the board, and know if the game is over. They don't need to know any of the details of how we do that, like that we broke it up here. This was just to make life easier for us. We didn't have to break it up here, right? I know I asked you if there were questions, and I'm talking about it anyway. I'm sorry. But this is just as we design our solutions, right, we want to take anything that shouldn't be used by other people and put it in the private section. Just makes life easier for us. All right, so then our connect for the game piece, right, is just a pretty quick little loop. Works out pretty quickly for a lot of these games, right? We can just make a little loop here that uses it, or if we were going to turn this into a web application, right? We give them a little web form they can submit, and we have ways to display it and get the board out and things. But the class code itself shouldn't have to change. Right? If we've done a good job of encapsulating all those details together, this class file can be used in a mobile app, it can be used in a web app, it can be used in a graphical user interface application, or at a terrible console application like this, where people type in a black screen. That's the least fun way to interact with code, but it's the simplest for us to get started. All right, cool. Let me fire up the iBooks here. Oops, which one do I want? No, learn.zybooks, this one. There's a different link. One of these links should work. There we go. Let's see. Oh, the C strings are awful. So, I don't know, did you spend a lot of time with this last semester, talking about C strings as arrays? Probably not too much. So back to the original C before C++. To have a bunch of characters, we had C strings, which were just character arrays. So like a char array of size 20 could fit Star Wars, but then there's some extra space hanging out there because we've allocated 20 spaces for characters. And the way that C knew that a string was done is you gave it a special null character at the end, which is this \0. So we could have, instead of using the string type that we use, they didn't have that. All they had was character arrays, and everything had to be end with this null terminator. There's a joke, I think I put it in one of the memes a while ago. So one of the issues with C is if it tried to read a string, it would just keep reading until it found a null character. So if you forgot to add the null character, it would just keep on reading and keep on reading and keep on reading and keep on reading. And probably the stuff it was reading, right, when we were accessing arrays and we tried to access an index beyond where we should have, it just gave us garbage. It would just keep on reading garbage and read garbage and read garbage and find more garbage until eventually it might have found a null character somewhere. Right, so not the easiest thing to work with. These are null terminated strings. So if we're doing literals here, our compiler does it for us, which is nice because we've realized, hey, you probably meant to add the null terminator yourself there. Right, so our compiler gives us some extra help along the way with these, which is super cool. You could do it yourself, or you could look for that null terminating string here, right? So we're trying to find, as long as it's not a null terminated string here, go look and see through here if we found the @ character, whatever it happens to be. So ways of working through strings is a little bit messy when you use these null terminator strings. And you can do it yourself if you wanted, right? You could make your own array of characters here and then add it yourself. That's just \0 is your special character there. They're not a lot of fun. Working with C strings then, we have a library to work with them for C string. So copying strings from one string to another works out really nice. So we'll copy up to that null terminator, so we don't have to reinvent the wheel for any of these things. So we can use these string copy functions. You can copy n number of characters. So take the first n characters. When we're doing a string n copy, you can concatenate right to the end of the destination string, just reads what's there, adds it onto the end. So you couldn't just say, here's a string plus a string and get a new string out. We couldn't concatenate manually. You had to do it with a string cat function here, right? Because if you take one array and add another array, it doesn't really work, right? And if we tried to say one array plus another array, let's see, should I just do, let me just throw it up here, right? If I have a int array values, we'll say 5, 4 and 5, and more numbers, 5, 2, 4, 6, 8, and 10. Oops, there is the comma. Right? If we wanted another like int array of, I don't know, sum, can we say values plus more numbers? No, we can't. Can't add. Now this is not the most helpful error. Expression must have integral or unscoped enum type. It's not the most useful error here, but you can't just add two arrays together, right? If we wanted to append one array onto another, we could do that, right? We'd probably need some sort of loop to do it, right? So if you don't want to have to do that, you can use string cat. That's all. Now, one of the downsides is people tended to make like really big string arrays, character arrays, because they didn't know how big of a string they were dealing with all the time. So you'd say, hey, give me space for 100. That's probably enough. Sure. You probably have enough room for lots of things with 100 characters. You know, most full names don't ever go to 100 characters between first, middle, and last name. It's pretty unlikely you'd hit 100 characters. It's a pretty safe limit if you're doing that. But say like 30 characters, you might run out of space if you're doing someone's first, middle, and last name. Right? My kids have a 15-character last name because we hyphenated, and Chernesky's already 9. So, like, yeah, they could run out of space pretty quick if we picked a smaller number. So a lot of times we just oversized. And it's not the most efficient thing. Now, for our purposes, we don't really care that much. You know, another 50 characters is, what, is that 100 bytes? So that's a pretty tiny amount here. But if you're dealing with millions of records, right, storing millions of people's of information, times an extra 50 bytes, it starts to add up, right? So, not the best way to go about it here. So thankfully that string class in C# or C++ saves us a lot of time, energy, and effort. We don't have to do a lot of this nonsense, but you'll still see some of this stuff out there. String compare, and they don't, string chomp, or I don't know, whatever, like, why is this compare? They couldn't type a couple more letters? I didn't write it, so I can just make fun of people who did. So you might run into some of this weird stuff looking at C++ code if it's made to deal with more of the older legacy C string stuff. That's all. So, and it's fine. It's okay. We just, like, it's obnoxious. That's all. It's just an extra tedious, more steps and things. Then we can even get into specific characters in CC type. For character type, it's actually kind of cool. This is fun. So if you want to do stuff one character at a time, if this is stuff you did at 150, just yell at me. I think usually we skip over this stuff because it's silly. So one character at a time, you can see if it's alphanumeric, if it's a digit, or sorry, alphabetic is a digit, is alphanumeric, alpha or number, numeric. If it's a space, right, so it's spaces, tabs, I think even the new line. Wow, where's that coming from? Blanks is a hexadecimal digit, right? So 0 through 9, A through F, we can look at. If it's a punctuation character, which is all sorts of, I didn't know those were punctuation, but sure, why not? We'll call those punctuation. If it's a printable character, this is kind of fun. So some of these things like the null terminator is not a printable character. Who knew? It's not one that prints. Or is a control character, like the null terminating character is a control character. That's a special character. That's special meaning. So some fun things there. Two upper and two lower, I think we've done a lot, especially when using menus. All right, awesome. So I think that gets us through everything in here then, right? Because we did the Pairing, we did the 2 dimensionals. Okay, this will make sense? Okay, I do want to spend real quick this reversing a vector here. This is a silly interview question we used to give just for some practice for people, just to have them talk through an easy problem, right? This was like the warm-up one. It was given some sort of array like this, how would you reverse this in place? So not making a new array, but reverse this array. So we'd write a function that would give it an array and reverse the sequence without using a library. Because, I mean, that might be easy enough, but that's okay. So we'd say void reverse given a, I don't know, we want a int array, probably a vector. A vector is going to be easier. A vector of int numbers, or to reverse. We'll call that to reverse. All right, so we make this a vector. Vector int numbers. All right, so if we wanted to reverse it without making a new one, or making a new one is the easy way first, right? So if we can say for int index is 0, index is less than my to reverse dot size index plus plus. So I'd want to make a new vector, right, of int to return. And we could take to return, and we just push back by to reverse at the index. Right, when we're done, we can return the to return vector. This is the lazy way, right? Oops, not a void. So this would be a vector type int. So we could return it. But now, if I pass it a really big vector, I have double that in memory now, which is probably not ideal. So instead of that, if we wanted to do it, let's do this as a void. So if I give it a vector, I can reverse a vector without returning anything. So looping through, and then if I don't want to replace anything, right, at the index, how do I swap things? Right? If I want to try and reverse this thing, what would be a way we could go through and reverse this vector without making a second vector? I know it's really early in the morning, and you've not had enough coffee with espresso.
You have to use like a temp value?
Yeah, probably a temp value. Okay, so we want an int for temp. What do you want to set the temp as? The first one? Okay, so my to reverse at the index. Okay, so now I've got the character here, right? So I'm going to go from the beginning all the way to the end. I can get the current character out as a temp value. Where do I want to put that temp value, or where do I want to put now that I've got that? Put it at the end? So set it, so to reverse at to reverse size -1, you said? Minus the index? And what am I going to do with this one? So this is the end minus wherever we're walking in, right? This one? Yeah. So set that one equal to this one first. Okay, so I'm taking the start here, and I've stored it off in a temp value, great, and I've taken the last one and put it in its place. Right, what's the next step then?
The value in temp should be...
Drop it in this place.
Yeah.
Right, so we'll set that one equal to temp. All right, so if we're thinking about it here, right, if I have 1, 2, 3, 4, 5. So we said, okay, well, 1 will be temp, and then 1 is going to replace with 5, right? So now I have 5, and then I'm going to replace the 5 with the 1. So I'll have 5, 2, 3, 4, 1. Right, and then my loop goes back up. Okay, add 1 to index, so now my index is 1, so my temp will be 2 here. I should have brought my drawing pad, I forgot. And then I'll set this location where 2 is to this value minus the index, so this will be the 4, right? Size is size is 5, minus 1 is 4, minus 1 for the index is 3, index 3, which is where we want, right? Because we have 0, 1, 2, 3, 4. Okay, so we swapped those. Cool. And then index is 2. So temp becomes this one. I put this one back on top of itself. Okay, index goes to 3. So my temp is 3 here, index 3. And then I'll change that one with size minus 1 minus the index. So I'm going to put back this value right here. Is that what we want?
Would you like, in the for loop, you divide the size by 2?
Yeah, we want to divide by 2, right? So stop in the middle. Once we hit the middle, we're done. Right? Otherwise, you reversed it twice, and if you reverse it twice, you're back to where you start. Okay, very cool. Yeah. So reverse. Okay. Now, it's upset because we can't overload by return here. Right? I can't have two things named reverse that both take the same list of arguments. So remember, when we look at overloading functions, the signature of the function is the name and the parameters, not the return type. Do you know why we can't distinguish these based on return type? What if I would say like new numbers equals reverse of numbers? How's it going to know which one to use? Right? If I say, yeah, they have to be named different, but we can't be based on return type because it's not going to know, hey, I want to return something necessarily here. Right? Or I could just call reverse of numbers. Right? You can call a function that returns something and just ignore the return. Or you can just call a function and store it as something. Right? So you got to be specific around it here. So this is reverse in place. How about that? Reverse in place. Given numbers. So they will both reverse. But this one is going to be more memory efficient, right? Because we don't have to duplicate all of our values. Again, most of the time I say that doesn't matter much if we're super efficient or not, but if you're dealing with thousands and thousands and thousands of numbers in a vector, you probably don't want to have to store them twice. Or if you did this as characters, right? And then I said, hey, here's a C string of the book of Moby Dick. That's a lot of characters in memory. Yeah.
So what's the difference between doing it like this and why would you need to like make the parameters like a reference? Like in some other case, like you use that so you don't have to make a copy, right?
Yeah. So if we pass by reference, passing a copy here is not actually going to work very well, is it? Right. We're going to do that. We're going to do that in just a second, but after we spit these back out. So we're going to just loop through. Man, print vector. This is really silly, isn't it? Vector of int to print. And we'll just print our vector. To print at the index. Sure. I just don't want to have to type much. Probably an end line. Sure. So now we can print our vector. Okay, so we can print vector numbers, and then we can reverse in place. We can print it again. Or this is before, right? Before reverse in place, after reverse in place. All this so we don't have to look at it in the debug view, right? That's okay. This is before reverse, after reverse, reverse in place, and then print vector, this one here, and then we'll print vector new numbers. Right. So we're going to print it, try and reverse it, print it again, try and reverse it, print it again. So let's see what we get. Oh goodness, we have build errors. Where? Really? You do? What? There it goes. Oh, I already had a vector called numbers. Oops. Okay. Maybe we should just name this something different then. How about numbers 2? I'm gonna just be lazy. Sorry. All right, let's try that. Oop. Okay, so we printed that 1, 2, 3, 4, 5 before the reverse in place. 1, 2, 3, 4, 5. After the reverse in place, I didn't print it again. Gotta hit print again. Print the vector. Oh, that was the before one. Okay. Let's try it again. All right, so before we reversed, 1, 2, 3, 4, 5, and we reversed in place, and we try to print it again, but it's still 1, 2, 3, 4, 5. Because you said, hey, we're not passing by reference, right? So passing by reference, then I can go and modify this thing, right? Here. If I'm gonna just reverse it here, I don't necessarily need the reference. Would save us a little bit of copying. Now we actually have 3 copies then, right? I'd have the original, I'd have the copy that I passed it to the function, and then I'd get the new one back. So now we've gone triple here if we don't have a reference. And then for printing, definitely we don't want to have to make a copy just to print it here. Let's try that again. I don't think we need this first print, do we? There we go. We'll get out this first print. So 1, 2, 3, 4, 5. Now we get 5, 4, 3, 2, 1 after it's reversed in place. I think I'm printing these in the wrong order. Let's put the print down here. Now we get a nice title, right? So before we reverse, we print it, we reverse it, print it again. We don't need the new one here. And then we want after reverse. All right, let's try that one. Oh, our reverse failed. Our vector out of range, it crashed. What happened to our function here? This is our reverse function. To reverse. So let's push back the to return at the index. Oh, that's my bad, that's my typo. There's nothing at the to return, we want a to reverse. Right? If we're looping through to reverse, we have to get the values from to reverse. That ought to fix that. Let's try it. All right, and then we print that one, and then it should be back, 5, 4, 3, 2, 1. After we reversed, because we reversed numbers 2, that should have been reversed. Shouldn't that have been back in the original? Right, numbers 2, 5, 4, 3, 2, 1. So the new numbers didn't get reversed. Oh, we didn't actually reverse anything. We took the first one. That's why you have to test your code. Right? We just took the first value and put the first value back. We wanted index because we wanted the last one, right, as we go. So -1, I don't know the size, right? So to reverse, dot size, -1 minus the index. Right, we're going to take the last one, and then the one in, and the one in, the one in, the one in, the one in, one in. Okay. Let's try that. Let's see if it printed out okay. Hey, now we get it reversed. 2 hops this time. All right. So that's just a silly exercise, but it points out pretty quick if people know how to deal with things in memory, right, without having to reverse them. Believe it or not, I've interviewed fresh college grads who can't do this. I know interviews are hard, but if you can't do this after getting a degree in computer science, it's pretty embarrassing. Can we admit that? Is that fair to say? Even though interviews are hard. Before you go on an interview, it's well worth your time to do mock interview practice to help get some of the nerves out. It's not going to fix it completely. You're still going to be nervous at interviews, so that's okay. But the more you've practiced in that environment, the more comfortable you'll be in it. Okay, so definitely spend some time with some of the groups do that. I think ACM does that. I think they're still around. They had some trouble during COVID, go figure. I think they're still an active group. Are they in Victor's link? Dearborn. Anyone use this anymore? Okay, let me see. thought they were there. ACM, are we still? Yeah, I think we're still there. Yeah, so reach out to them. They're a pretty cool group. You can't join yet. I forget what their rule is here. You need so many credits or something like that. What was it? ACM.org. Was it this one? I thought it had a thing. I don't know. Reach out to them and ask. At one point, you had to have so many credits in CIS before you could join. But they're a pretty cool group. ACM is one of the oldest and largest computer groups out there. Computing machinery sounds really funny, but mostly that's those CIS folk. So I used to do a lot of cool stuff. Career services, cool too, for mock interviews, or just get together. You can Google most questions, right, from interviews. People post their interview questions and stuff they get asked. You can find most of that stuff online now, which is pretty nice. So if you know who you're going to interview with, check out what the interviews are like. Right? That way you don't run into reverse this and just fail, which is real sad. But it's quick. Hey, like 5 minutes into the interview, we know we can call it quits, and I don't have to waste an hour talking to you. Or them, not you, sorry. You folks will all do great at this, right? Okay. The interview system is a little bit weird, but it's sort of what we have, what we work with. So hopefully it's not a whiteboard interview. We're realizing those are terrible, and more people are getting away from them because no one really cares if you can solve something on a whiteboard. Not everyone. A lot of people don't care anymore because why would you have to have all that stuff in your head? So the idea with whiteboard interviews is that we want to see if you can talk about your ideas. Right? Talk through, hey, this is how I would go solve these problems. This is the steps I would take. That's what we want to see in candidates. So believe it or not, you don't actually want to be an antisocial nerd who knows lots of stuff. Right? That doesn't go well for you because you have to work in an organization. You have to work in a team. You have to work with people when you write software because people use your software. So depends how that goes. All right, we feeling okay with arrays? Two-dimensional arrays, vectors, two-dimensional vectors, playing with that? Cool. So if you've got a question about the lab, let me know, or we can chat Tuesday as well. Don't sweat that. And then I'll post these quizzes. I got to go turn those on for you here and fix the dates because I shamelessly copy-pasted here. So let me go edit this one. And then I forgot last week's as well because, yeah. Let's go close that. There we go. I can go back. So is like a week good for that? For these ones? Okay, cool. I'll do that one. And then this one on, we didn't do a whole lot on UML, did we? I gotta come back to UML. So if you get a UML question, don't worry about it too much. But we talked about unit testing, right? We did unit testing. We did inheritance. We'll spend more time on that in the next project as well. We're gonna do recursion. Let's see, close all those out. Okay. All right, awesome. You folks take care. I will see you Tuesday then.